In this series, we are building a task management application. And in the last video, we finished our repository layer, our service layer, our handler layer. We also created Zod schema and OpenAPI contracts, and we finally generated our OpenAPI.json file. And we tested most of the APIs in our Scalar interface, which is this one. And in this video, we'll continue our project. And the plan for this video is to wrap up whatever is remaining in our whole project. And there are still quite a lot of modules that we need to add, but the majority of them are the first, the ability for to-dos to add attachments, which means that we need to add the ability to upload files and download files. And for that, we'll be using an S3 compatible storage, which is Sevala object storage. We have already created our keys and added it in our .env file in the first video. So in this one, we can directly proceed to our implementation of upload download functionality, and also all the endpoints, the repository methods, services, handlers, DTOs, models, etc., whatever we need for our upload and download feature. After that, we'll proceed to add our Cron processes. As I mentioned before, it is a to-do management application, and you want to set up some Cron processes. Processes like every day we'll send a report to our users that you have these many tasks that are overdue. And we'll also send a weekly report to our users showing them the summary of all the tasks they finished, all the tasks that are pending for the last week. So a couple of cron processes. And the last thing, we also want to add some integration tests. Integration tests using test containers and Postgres for testing our repository layer. And with that, we can finish our project in this video. And in the next one, we'll go ahead and deploy our project on the cloud so that your users can access it using whatever domain you provide. So let's jump into it. The first thing that we need for our attachments module is creating database support. For that, we'll need to add migrations to support attachment feature to our to-dos. So let's stop this server and create a new migration. Migrations new, and the name is attachments. So we'll create a new file. Let's clear that. And the first thing that we need is create a new table called to-do attachments, which is going to look like this. Again, it has a couple of default fields, which all of our tables have. Then the to-do ID, which references the primary key of a row in our to-dos table. The name of the attachment, basically the name of the file uploaded by the user who uploaded this file. Download key, which is the key that we'll get when we upload our file to S3 or Sevala object storage or Cloudflare or to whatever object storage that you use. Then the size of the file, the MIME type of the file, which are not mandatory. We have kept it in case we want to record the metadata. After this, we also want to add a couple of indices and also the trigger so that this field updated at is automatically updated to the current timestamp every time we update our row. For that, we have created two indices, one on the to-do ID and one on the uploaded by. Next, we have added our trigger to automatically update our updated at field. The next thing we should do is create our models and DTOs. So for models, let's go to our model and to do. Inside that, we'll create a new file called attach.go. The package will be to do, and this is what our model is going to look like. The model base will embed all the default fields that we need, ID, created at, and updated at. Then these are all the fields. Since file size and MIME type are optional fields, we are adding the pointer type here. All the other fields are mandatory. That's why they are of value type. We have to do ID, name, uploaded by, and download key. Once we have our model, we can add all the DTOs that we need for our upload and download functionality. So let's go to our DTO, and on the bottom here, we'll add all our DTOs for our attachments. The first thing is, of course, we need an endpoint so that we can upload our files to our server and attach it with a particular to-do. For that, this is the DTO that we are going to use, is upload to-do attachment payload. In the path, we are expecting a to-do ID, and this will send the data, the file data, in a multi-part form. That's why we are not validating anything here. We'll validate that in our handler layer where we can access the data of our form. Then our default validation logic here. Apart from this, we'll need two more endpoints, one to delete our attachments and one to download our attachment. And for downloading a particular attachment, we'll be using a pre-signed URL flow, which basically means that if we want to download a particular file, you will request the front end, the client will send a request. It will make an API request to our server, to our backend, and our backend in turn will make a request to S3 storage or Sevala object storage or Cloudflare R2, whatever that you are using. The kind of setup we have, you can use any of them, but our backend will make a request to the object storage and it will retrieve a pre-signed URL and we'll send that URL to our front end. And then our front end, our client can make a request to that URL so that it can finally download that file. So these are the two DTOs that we are going to use. First is the delete attachment. For this, we'll expect both the ID of the to-do and the ID of the attachment in our path parameter. Then comes our validation logic. Next up, for getting the pre-signed URL or for our download endpoint, again is the same. We are expecting to-do ID and attachment ID in the path parameters. That's pretty much all the DTOs that we need for our attachment module. Next, we need to make some changes to our existing stuff. So here, if you see in the populated to-do struct, when we are fetching the information of a single to-do, now we also need to send all the attachments of that to-do. So here we need to add another field called attachments, which is going to be the type to-do attachment struct. And the tags are going to look like this. This will be attachments and this also will be attachments. We have updated our populated to do this part. Then we'll also need to update our repository method where we are fetching all the attachments for a particular to do. So if we go back to do repository, we need to update two methods. One is get to do by ID. Here we'll need to add the information about our attachments and also get all to do's. Need to update both the methods. Now going back to our query here, where our from statement ends, we need to add one line, which is another join with our to do attachments table, which is going to look like this. Whatever we have up to this point, we join that as a left join with to do attachments table. We name the alias as att. And the condition is att.todoID should be the same as t.id. Now to fetch the attachments, we need to add another section here. So let's add a comma here and enter. Again, it's performing the same kind of operation that we have here. But in this case, we are fetching all the attachments related to a particular to-do. Same way in get all to-dos API, let's add a comma here and enter, paste it. And for this, the same thing. Now it will also return all the attachments. For that, if you want to test that out, first thing we need to up the migrations. So let's expose the variable, which is tasker dbdsn. Then let's run migrations. Yes, and our attachments table should be ready. We want to check that out. Let's go to proxmox. In the database, let me select tasker. And here you can see there is a table called to do attachments, which means that our migration is successful. Now, if we go back, let's come here in our Scalar interface. If we run this API again, first let's start the server, run, let's come back and send this again. And when we do this, we'll get another field called attachments. For now, the array is empty because we have not created any attachment, but at least we are fetching all the attachments related to this particular to-do and sending a field. And same for get all to-dos API. Okay? There is a field called attachments. Next, we also need to update the Zod schema because that is directly linked to our contract. So if we go to our to-do index.ts, in the populated to-do Zod schema, we need to add the support for attachments here. But before that, we need to create a schema for our attachment. So this is what the schema of attachment should look like. Z to-do attachment. And these are all the fields of our attachment, which is directly mapped from our database table and our Go data structure, which is the Go struct, our model basically. Then let's come here, add a field called attachments. It's going to be z.array of z to do attachment. And once we add this, we should go ahead and generate a new contract, a new openapi.json file basically, so that it is visible in our Scala interface. Because for now, if you go here, let's close this, and in the response type, if you check, we are getting comments and children category, but there is no field called attachments. So we need to update the contract. For that, let's run one gen. Once we have done this, let's open the network tab. Make sure the cache is disabled. Then let's refresh. After refresh, once you scroll, you should see that the attachment fields is added and this type is also correct. Great. Now that our setup is ready, we have created our model, we have created our DTO, we have added support in the get to do APIs. The next thing we need is a module which is going to be used for uploading files and getting pre-signed URLs. So for that, we need to create a functionality inside lib, right? And since we are using AWS SDK for the whole thing, whether we are using Sevala Object Storage or Cloudflare R2, let's name this as AWS. So we'll create a folder called AWS, and inside this, we'll create a file called aws.com. And we'll also create a file called s3, which will contain all the logic for dealing with our object storage. Now the package will be AWS, and we'll create a struct for including our S3 client and also an instance of our server so that we get access to our logger, our config, and DB instance, whatever we need. So let's create both of these. This is our server instance. We have created a struct called S3 client and embedded both our server instance and S3 client instance. And this is our initializer function. This is giving us error now. So let's run go mod tidy so that the error goes away. Backend, let's stop our server, go mod tidy. And once that is successful, these errors should go away. Actually, this is the wrong package. The actual package that we should be using is the v2 one. So in the end, let's write v2. Now we have our struct for S3 client. Now here we need a couple of functions. The first function is of course to upload a file. And this is what it is going to look like. The name of the function is upload file. This is the receiver method on top of our S3 client. And it takes a context, a name of the bucket, the name of the file, and the actual file. And it returns a string and an optional error. The string will be the key that we finally get after an object or any file is uploaded into our bucket. The first thing that we do is create a unique key for our file. And we do that using a timestamp in the Unix timestamp and embedding it into the end of the file name so that even if we upload the same file multiple times, the names will always be unique. Next up, we create a variable for a new buffer and we copy whatever the content of this file into this buffer. And finally, we call this method called putObject, which is coming from our AWS S3 client, and we pass all the required parameters. The parameters are, first thing, the name of the bucket, which we have in our config, in our .env file, then the name of the file, the key of the file basically, which we created here, then the content of the file, which is provided in bytes, then the content type, which we automatically detect based on this detect content type. And finally, we execute that. If there are any errors, we return that error. Otherwise, we return the file key that we generated. And this file key will be useful when we want to actually download the file or we want to delete the file. So the next method should obviously be how to download the file. So as I said, to download the file, we'll use this workflow called pre-signed URL, and this is how we'll do it. This is the function, which is create pre-signed URL, takes a context, the bucket name, and the key, which is the key that we generated here, and it returns the string, which is basically the URL, the pre-signed URL that we get from the AWS server, the Sevala server, or the Cloudflare server. We create a new pre-signed client. We set an expiration, which is around 1 hour. So this link, this particular URL will be valid for the next 1 hour, and the client, whoever has access to this URL, they can download the file, they can access the file up to 1 hour using this URL. Then we just call this function, which is pre-sign get object, and we pass all the parameters, the bucket name, the key name, and the expiration. If we have any errors, we return that. Otherwise, we return the URL that we got from the pre-signed URL. Now that we have upload and download functionality, the last thing we need is some way to delete the object from our object storage. Because when an attachment is deleted, We also want to free up some space from our object storage. That's why we are adding this method. This is pretty simple. We take the context and bucket name and the key name, and we just call the delete object method of our S3 client. Then we return nil. Since the object is deleted, there is nothing to return here. And that's pretty much all about our S3 client. Now let's go to our AWS clients so that we can initialize our S3 instance there. Here we also create another struct for our AWS client. We name it as AWS, which is and inside this we'll embed our S3 client. S3 is going to hold a pointer to S3 client. After we have this, we need a function to initialize AWS client. This is going to look like this. This is the signature of the function. We take the instance of the server and we return the pointer to our initialized AWS struct, which will have the S3 client inside. The first thing that we need to do is initialize the configs, but we have a couple of errors here. First is the import error. So we need to run gomod id once, gomod id, and after that the import errors should go away. Then we have an error here because we have not added our configs for our AWS configs. So let's go inside our config and see inside our config. We need to add another struct here, which is type. It will have region, access key ID, secret access key, upload bucket, and endpoint URL. If you have followed the first video where we copied all this information from Sevala dashboard, then you should already have this in your .env. Here we are just reading it into a struct, and in the primary config, let's just embed it AWS, which will be of type AWS config, and this is going to be the tag. Now if you go back, this error should go away now that we have configured our configs for AWS. At this step, we are constructing our config. This snippet is taken from the AWS docs using Go SDK. Next up, since we are not actually using AWS S3 for this project, we are using Sevala's object storage, which is compatible with AWS S3, but it is not actually AWS servers. That's why we need to add another step so that we can configure a different URL, a different server URL for our object storage, which is going to look like this. If it is AWS S3, then we won't provide an endpoint URL and this step will not be run. But if it is something like Sevala or Cloudflare R2, then we need to configure this so that we'll have a different URL from AWS servers. And finally, after we have configured the URL, we'll load the config and we'll pass whatever config that we have created. And finally, we'll return the initialized AWS struct with the initialized S3 struct inside. And using this AWS service, we can add upload and download functionalities in our app. But before that, we need to initialize this AWS service first. So let's go to services, and here after we initialize our auth service, we also need to initialize our AWS client. For that, we'll just like this. We import our AWS package and we create and initialize a new client, and we'll pass that client to our to-do service. So here in the end, we'll pass AWS client, which we are going to use in a bit. But for now, we'll just pass it so that we don't have to come back here later on. With that, we are ready to work on our repository methods for to-do attachment. We'll add the repository method in our to-do repository only since it is part of the to-do module. So let's go to to-do repository, which is here. And in the end, we'll add all the methods for attachment. The first function is going to be get a particular attachment of a to-do. And this is what it's going to look like. We take the ID of the to-do, the ID of the attachment, and we return an instance of the to-do attachment model. And the query is pretty straightforward. Select star from to-do attachments where to-do ID is this, attachment ID is this. Run the query. If error, handle it here. Otherwise, collect the row and store it inside the attachment struct. If there are no rows, send a not found error that attachment not found. Otherwise, return the attachment. Same way, we also need a method for fetching all the attachments of a single to-do. And for that, we take the context, take the ID of the to-do, and the query is pretty similar. Select star from to-do attachments where to-do ID is this, and order by created at descending, so that we fetch the recently created attachments first. And these are the same thing, boilerplate that we have: error handling and deserialization, and return the result. And in the end, we also need a function for deleting a attachment. For this, we take the ID of the to-do, the ID of the attachment, and we just run a delete statement where to-do ID is this, attachment ID is this. Then we run exec because we don't expect anything in return. Then If rows affected is 0, which means that we cannot find anything with these conditions. That's why we send a not found error with attachment not found. Otherwise, we return nil. And in the end, in the handler layer, we'll return the status code of 204, which is no content. And that takes care of our repository methods. Next, we'll have to go to a service. The first thing that we need to do is take the AWS client in to-do service. So here, let's create another field called AWS client. This will have an instance of the AWS struct, and in the initializer function also, we need to take AWS client, which will pass from the services struct. Then in the end here, AWS client, which will be AWS client. Now that our to-do service has access to our AWS client, we can perform upload and downloads. The first function that we need for our service layer is to upload a new attachment, and this is what it's going to look like. We have a method called upload to do attachment. It is going to take a context from the handler layer, ID of the user, ID of the to do, and the file, which is a multi-part file which we are going to send from our client or our front end. Again, the same pattern that we do in our service layer. We take out the logger from our middleware, then we check that whether this particular to do exists or not, which we are passing from our handler layer. If it exists, we proceed. At this step, we try to access the file, whatever file that we have received in the format of multipart. If we cannot, we send a bad request error. Otherwise, we proceed and we defer the closing of the file so that this statement will run at the end of this function, even if we forget to add this at the end. That's the user defer. Then we finally call the upload file function using our S3 client, where we pass our context, request context, the name of our bucket, which we are getting from our config, the name of our file with a prefix of to-do/attachments, then the file content itself. If there is some error while uploading this file, then we return here. At the next step, we are trying to detect the MIME type, which is basically what is the format of the file, whether it is a PDF, whether it is an image. We are trying to detect that. And after we detect it, we store it inside this variable called MIME type so that we can store it in our to-do attachment row. And finally, we call our repository method to upload a to-do attachment, which creates a new row in the attachments table for this particular attachment, for which we are getting error because we forgot to create this particular method. This should be to-do ID. So let's go ahead and create this method, which we forgot to add. Let's go to the end. In the end, we'll create this method, which is upload to-do attachment, which will take all the information that it needs for creating a new row inside to-do attachments table. Then it executes this query and returns the final created attachment. Now we don't have the error here. Then we call the repository method here. If there are any errors, we return and log the error. Otherwise, we log the information that a new attachment is created and we return the new attachment back to our client. After this, we also need a method for deleting attachment, which is going to look like this, where first we take out the logger from our middleware, then we check whether this particular to-do exists or not. Then we try to fetch that particular attachment from our database. If that does not exist, we return from this point. And finally, we run our repository method to delete that attachment from our database. After that is successful, we spin off a new Go routine so that asynchronously, without blocking the response of this request, we delete the particular object from our object storage. That's what this part of the code is doing. And in the end, we just return nil because we intend to return the response as 204, which is no content. Finally, one last method that we need is to get the pre-signed URL so that the front end can implement the download functionality, which is going to look like this. First, we check whether the to-do exists or not. Then we try to fetch that particular attachment. If we cannot, we return from that point. In the end, we call this function that we created in our S3 client to create a new pre-signed URL. And finally, we return the URL back to our client, which it can use to download the file or access the file. And finally, we need to go to our handler layer to add the methods here. Going back, our handler, to-do handler, and in the end, we'll add 3 methods, which we just added. The first one is upload to-do attachment. Here we are adding some extra steps. It is not like the other handlers because we have to handle our multi-part form here. Let's just take a couple of validations. First, we check if a particular multi-part form exists or not. If it does not, we send a new bad request error. Then we check whether at least a single file exists or not. If it does not, then we send an error there. Then we check if multiple files exist. Since in this endpoint, we are only supporting say single file. If the client is sending multiple files, we send an error there. Finally, we pass our to-do ID and the content of the file to our service layer. Here we are getting an error because of a data type mismatch. So let's go to here. Instead of string, this should be a UUID dot UUID. Let's copy that. We'll also need this here and here, here and here. Now going back to our handler, the error should go away. Then for delete attachment, it is pretty straightforward. We are just calling our service layer method and passing the response. And for getting the pre-signed URL, we're doing the same thing. We are calling our service layer for fetching the URL, and we are constructing a new struct which has a field called URL, and we are sending that as a response. And that's all about our handler layer. And finally, we'll have to add this in our routes. If we go to do route, which is this file, in the end, we can add a couple of routes for our attachments. We create a new group with the /attachments. First endpoint is for uploading a new attachment. Then we have an endpoint for delete, and also one endpoint for getting the pre-signed URL for that attachment so that the client can download it or access it. And even though we have created these routes and handlers here, but in order to test this, we have to add these endpoints to our contract, so that in our Scalar interface, we can upload files and check if this whole thing is working or not. So let's go to our contract, just todo.ts. In the end, I'll add all the endpoints for our attachments. First thing is upload to-do attachment. And here the content type is multipart form data. That is the only difference. And the response is a to-do attachment. Delete, the response is a 204. And for getting a pre-signed URL, the response is a URL. With that, we can go ahead and generate a new contract. So inside OpenAPI package, we can run gen, which will update our OpenAPI.json file. And we also need to start our server, and that starts our server. Let's go to our Scalar interface, which is this, and let's refresh. Disable cache is on, and let's hit refresh. And here we have our endpoints for uploading, deleting, and getting the pre-signed URL. So let's upload a new document and see if it's working or not. First, we need to add the token here. So the previously copied token, start here, paste the token here, and send it. Great. Invalid UUID length. We need to pass the ID of the to-do. We do get all to-dos. Let's copy the ID of a particular to-do and let's pass it here. Then we are getting the error that no file found, of course, because you have to upload a file. Let me add a file here and hit send, and we can see that the file is uploaded and we have got the key of the file and it is assigned to do. So now if you go to get all to dos and run this, in the attachments we are getting our file. The MIME type is PDF, the file size is this is the download key, etc. Now if you want, we can go to our Savala dashboard. Let's go to object storage section, tasker, and in to dos attachments you can see our file here. It's working. And let's see pre-signed URL flow also. So if you go here, we need two things. One is the ID of the to-do. Let's paste that here. And also the attachment ID. Copy that and paste it here. And let's send it, which gives us a URL. Let's copy that and let's see if we can paste it here. You have to get rid of the extra characters, and also great. We can access the file here, which means the whole upload download functionality is working. And with that, we have finished our attachments module. For the cron process, the requirement is we want to send our users daily report, daily reminders for their overdue tasks, and also weekly report of what are all the tasks they completed this week, what are the tasks that are pending, etc. And we need a couple of modules for the whole thing to work. First thing is we need to create all the repository methods so that we can use that to fetch the data that we need, which we can send to our users. Once we have that, the next thing that we need is we have to create a couple of email templates that we can send our users. And after that, we have to create email jobs, our background processing job, which is actually going to send the emails. Then finally, we'll have to create our cron registry. This is going to trigger the background job. Then background job is going to send the email to our users. Let's start with the repository method so that we have an idea of what is the data that we are sending to our users. So let's go to the bottom of our to-do repository. We'll add all the functions that we need for our Cron requirements. Great. The first function that we need is this one, which is get all the to-dos due in hours. So we'll pass a value for this hours variable, and by default it is going to be 24 hours. And what this method is doing is we are fetching all the to-dos of all users basically, and the requirement is there should be a due date. Due date should not be null. In that case, there is no sense in getting the overdue to-dos, right? We cannot know that. So the due date should not be null, and we are fetching all the to-dos in the last 24 hours, which are not in the status of completed or archived. And that's what this query is going to return us. And this is, as we already know, is the boilerplate to finally load our fetch to-dos into this variable, which is to-dos, which is a slice of our to-do struct. That is the first function. Then we also have a similar function, which is get overdue to-dos, which is almost the same as the above function, but in this case, we don't have the requirement of hours, which are basically fetching all the to-dos before the current timestamp, which are not in the status of completed or archived. Next, we have a function called get completed to-dos older than. And the requirement for this is we are past a particular time, a timestamp, which is a date and a time, and we are fetching all the to-dos that are older than that particular timestamp. That's the use of this function. The next function is pretty straightforward. We pass a slice of a bunch of to-do IDs, and for all those to-dos, we make the status as archived, and we don't need the updated now since we are already doing that using a trigger. So that's pretty much all this function does. And we use this because we want to provide users a functionality that after 1 month, all their to-dos which are in the status of completed, they automatically are converted to the status of archived so that they don't clutter their dashboard. Next up, we need a function for fetching all the data that we need to send a weekly report for all users. And this is what it's going to look like. But first we have to create the struct to send this data in. So let's go to our to-do model, and somewhere let's paste. We have this struct which has user ID, created count, completed count, active count, and overdue count, which is basically different parameters for the number of to-dos that the users have. Now going back, this error is gone. And in this query, what we are doing, we are passed a start date and an end date. And for that time frame, we are fetching different metrics. The first metrics is basically how many to-dos are created in that time frame. Similarly, the next metrics is how many to-dos are completed in that time frame. Next one, how many are active, and the definition of active is the status should not be either completed or archived. And the next is overdue, which is the same as active, but the due date is already passed for that. We collect all these metrics and store it in this particular struct and return it as a response here. Similarly, for the next function, we are fetching all the completed to-dos for the user. But except this time we are returning all the populated to-dos instead of the lean format. And we have already seen this query, which is pretty much the same as get to-do by ID. So this is collecting all the to-dos. It's also collecting the category, the populated category, the children, and the comments of that to-do. Next, we have a function for fetching all the overdue to-dos for a user. In the previous one, we are fetching all the to-dos which are completed. But in this one, the data structure is pretty much the same, but here we are fetching all the to-dos which are overdue. With that, we are done with all the repository methods that we are going to need for implementing our cron process. So next up, we should go ahead and implement email templates that we are going to send to our users. So for that, we'll have to go to our packages, and inside emails, we'll be creating new templates. For now, we only have welcome, only one template. We'll add more templates here just now. So we'll need 3 more different types of templates. The first one is due date reminder.tsx, and we are going to define it using React email. And this is what the whole email is going to look like. I'm not going to explain how React email usage works, which you can explore yourself. But this, we are going to compile it so that it generates a pure HTML template which we will be able to send using our recent Go SDK. Let's check if replace all the instance of Alfred with Tasker, and that should be enough. Next up, we also need a template for overdue notification, and this is what it's going to look like. Let's also replace this with Tasker, and the third template is our weekly report dot t6, and this is going to be the content of that. Here also we can replace it. Great. With that, we have defined all our templates in React email, and to generate the HTML templates, we have a script here, which is the export script. So let's cd into our packages / emails, and let's run one. And after we run this, if we go to our backend folder, which is templates, here we have all the newly created HTML files, which we'll use to send our users the emails. Perfect. Now that we have our templates ready, we can go ahead and work on our background job processing for sending these emails. We have kept all our background job processing config inside lib, inside job. So first, let's define our tasks. For now, we only have email welcome task. We'll need two more tasks. One is for reminder and one is for weekly reports. Then we also need to define the data structure for our reminder email task, which is going to look something like this. It should be Google. For our reminder email task, we have a user ID, the to-do ID, the to-do title, the due date, and the type of the task, which can either be due date reminder or overdue notification. Both come under the same reminder email task. And to run this task, to push this task into our queue, we need a function for that, which is going to be this. It's going to take an async queue client, our background job processor, the task of type reminder email task that we just declared here, the struct. Then it's going to marshal the whole struct into a JSON, a bytes format. Then it's going to create a new task with maximum 3 retries, default queue, and the timeout of 30 seconds with the task type of reminder. And this is the payload, and it is going to push this particular task into our queue. Same way, we also need a struct for our weekly reminder task. This is going to be this one. It has a user ID, the week start and weekend. When do we consider the week to be start and end? The different counts, for example, completed, active, overdue, and also information of our completed to-dos and overdue to-dos, which are going to be the populated to-do struct format. And after this, we'll also need a function to push this task into the queue. And this is going to be enqueue weekly report email. This is going to take an async queue client, a task of type weekly report email task. Then it is going to convert it into JSON bytes, create a new task, and push it finally into the queue. With that, we have defined our email tasks. Now we also need to define the handlers which are actually going to execute this task. For now, we just pushed this task into our queue, but we also need handlers, the consumers basically, who are going to take this task out of this queue and they are going to execute it. And we keep those inside our handlers.go file. So let's minimize this, which is already implemented. The first task that we need to create is handle reminder email task, the first email type. And this is what the function is going to look like. We create a new function called handle reminder email task. We take the context and a task type, which is of async queue task, and return an optional error. Then we unmarshal whatever the JSON bytes that we get from that task into a variable which is of this struct. Basically, in the previous step where we are pushing the task into the queue, we're marshalling it. But when we are trying to execute this particular task, we need to marshal it so that we can access the different fields using our Go struct. We add a very comprehensive log for debugging purposes. Then we move on. The first thing that we need to do is we need to fetch the email of the user using the user ID that we got from this task. For that, we need to access our auth service. So first, let's go to job.go, and here we need to add two things. First is our auth service, and second is our email client, of course. Now, auth service, it is going to be an interface in case we change our authentication provider later on. So this interface is going to have one method, which is get user email, and that is going to return a string and an optional error. and it will take a user ID and a context. We also need a way to set this auth service here. So for this, we'll add a new receiver method for set auth service, which is going to take the pointer to the job service and embed this auth service into the job service. Now going back, that we had reached here. At this point, using this method, get user email, we will be able to get the email of the user. But before that, we actually need to implement the get user email method on our auth service. But we'll come back to that later on. First, let's go through this handler. After fetching the email of the user, we reach here. And this is a switch statement because a reminder email task can be of two types. One is a due date reminder and then is an overdue notification. So depending on what exactly is the task type, we need to send different data inside it. So for inside email client, we need to add two methods here. One is for sending due date reminder and another one for sending overdue notification. So let's go to our email client. Let's populate these fields. We need to add different templates that we created, which are going to be these three. Then let's go to emails. We need to add different methods to send different types of emails. For that, let's add them here. We're adding all the templates that we created in our React email package. We need to add the identifiers here. Then post that, we need to add a couple of functions here for sending due date reminder email, overdue notification email, or weekly report email. And all the functions pretty much do the same thing. They construct a map for all the template data that the email needs to send to the user, and they pass that particular map into this send email function. The same thing for this function and same thing for this function. After we define all these functions in our email client, we come back to our job processing handler. Depending on the type of the task, we trigger that particular method from our email client. If there are any errors, we return from that point. Otherwise, we log it and return nil. So our handle reminder email task is successful. And the last handler that we need is handling our weekly report email. And this will also follow the same structure. We unmarshal whatever the data that we need from our queue. Then we log a comprehensive log for debugging purpose. Then we get the email of the user using our auth service. Then we send the weekly report email using this email client method. If we encounter any error, we log it, otherwise it's successful. And that's pretty much all about the job handlers that we need to add. Here we added a receiver method that we can call this set auth service on our job service. So we actually need to call this somewhere. So we can do that in our services.go file. And here, after initializing our auth service, we can call this method. On top of our job service, we are calling this method is set auth service, which is giving a type error here. We go here. I think there must be some kind of error. Okay, I got it. This error is because auth service that we currently have, it does not really implement the get user email method. So we actually need to implement it to satisfy the interface. So if we go to our auth service, we don't really have any receiver method. So let's add the get user email method here. We need to import this clerk user, add it in the end. And what we are doing here, we are taking the context and the ID of the user, and we are just calling clerk's API, which is clerk user.get, and we pass the user ID. And using that, we are extracting the email address and we are returning it. Now, if you go here, the error should be gone because we now have a method called get user email. Great. Now in our job, all the handlers are present, but these are still not used yet. So if we go back and in our job, we actually need to initialize our handlers here using our mux handler func. So let's add the two types of handler that we just created, which is one is handle reminder email task and the second one is handle email task. And if you come here, it is now pretty much complete. Great. Now that our email templates are ready, our background job processing modules are ready, the final piece of this module is the cron process. And the way we are going to deploy our cron processes is going to be through Sevala. They have a dedicated feature for deploying your cron modules, how to trigger them, how often trigger them, etc., etc. So the actual code for triggering our crons or cron jobs will not be in our code base. It will be in our infrastructure level when we deploy our application. But the executables, the functions or the modules that is going to get triggered, that part we have to write. And then we'll provide the address of that module to our infra where we are going to deploy, and it is going to hit that particular function in that particular interval to trigger this cron process. So that is the final piece that we have to write now, which is the cron module. For this, let's create a new folder inside our internal called cron. The first thing that we have to keep here is the whole cron job struct, which is going to contain pretty much all the different types of services. For that, let's create a file called base.go. The package name is cron, and we are going to create a struct called the job context, and this is what it's going to look like. Has a couple of fields. One is an instance of our config, an instance of our server, an async queue client, because this cron command or this cron job is going to in turn trigger our background job processing server. It is going to push tasks into our queue, but it won't actually send the emails. The email sending part, that is going to happen through our Redis queue, through using async queue and our background job processing consumers. Then an instance of our repositories and our log service. We are doing this because our backend service, which is going to run our API, that is completely different from our cron job. This is a completely different standalone module, which is the cron command or cron executables, which has nothing to do with our API server. And that's why we also have to embed pretty much all the services, all the instances that this executable needs inside this struct. After this, we need a initializer function for this, which is going to look like this. The name is new job context, and it is going to return an instance of the job context. And somewhere here, it is calling the init job client to initialize our clients for our cron jobs. For that, we have to create a function, which is going to be here. Is called init job client, which is basically creating our Redis config and creating a new async queue client and returning that client for our background job processing. Then we'll also need a method so that we can gracefully shut down this cron job. And here we are just closing our database pool, our Redis instance, our background job client, and our log service. After this, we can go through this initializer function where we are loading our config. We are initializing our log service, which is a zero log service, then our new relic service, and then we are creating our new database instance with pooling and our Redis client, and we are passing all of that into our server struct. Then we are also initializing our background job processing client through this function that we declared here. Finally, we are creating our repositories by passing the server instance. And then in the end, we are returning our instance of job context with config, server, our background job processing client, our repositories, and our log service. Then comes the interesting part. So in our cron process, we are going to define different kinds of cron jobs, and all of them will have certain kinds of characteristics. To cover all of them without repeating our code, we can create an interface which is called the job interface, and it will have three different methods. One is name, second is description, and a method for actually running that particular job, which will take a context and take an instance of job context, which is this particular struct that we are returning. And then it will return an optional error, which is actually going to run our cron job. Next, we define a struct which is called job runner, which has two fields, one for our job, which is the actual cron job, then our job context, which has all the required fields like server, our config, our logger service, and our repositories. And to initialize this new job runner, we create a new function which takes a job and returns a instance of a job runner by initializing a new job context. And finally, we need a method to actually run the cron jobs. And that's going to be this run method. First, we are closing our context when this function returns. Then we are logging that we are starting our cron job. We are creating a new context. And then we are actually calling our run function of our cron job. If there are any errors, we log the error and return it. Otherwise, we say cron job completed and return nil. And that's the base setup that we need. After this, we can go ahead and create our cron jobs. This is going to be v9. For that, we'll create a new file called jobs. Here we'll define all our cron jobs. So let's define them one by one. The package will be cron, and the first job will be our due date reminder job. For that, we'll define a new struct, which is an empty struct, but since we have defined an interface here, which is here, so that struct will have all three methods so that we can finally consider it as a job runner since it has all three methods. Now from here, we need to define the method name, the method description, and the method run, which is actually going to execute the cron job. So for the name and description, we can define it like this: due date reminders, that's the name of the cron job, and this is the description, what does it actually do. And for our run method, this is what it's going to look like. But first we have to define a couple of configs for our cron jobs. So let's open config and we'll create a new struct. Let's say somewhere here, which is going to hold all our configs related to how many days do we want to wait after we automatically archive all the completed jobs of the user. Then what is the maximum batch size when we are sending emails to the users? What is the default reminder hours? And then the maximum to-dos per user notification. How many to-dos that we want to cover for a user notification when we actually send the email. So these are the parameters that we want to control from our environment. We can go ahead and declare a default config for all this, which is going to work pretty much the same in all the environments. Archive delays, for archiving, we take 30 days. Batch size will be 100. Reminder hours will take 24 hours. In the last 24 hours, we'll take into account. And the maximum to-dos for user notification is going to be 10. And finally here, if the cron config is not passed, we can go ahead and add it here. For that, we need to add cron here. And this is going to be an optional config since we have a default config here. And finally, this error should go away. And here, if the cron config is not coming from environment variable, then we are initializing from this function, which is going to pass all these values. Now going back, if we go to jobs, the error should go away. Then we can explore what we are actually doing here. Now, when we actually run this particular cron, this is due date reminders. What happens? First, we fetch all the to-dos that are due in the last 24 hours. We have already defined this repository method and we can see it here. We just defined it in the start of this video, and we call this particular repository method, which returns a slice of to-dos. Then we log some information, how many to-dos that we got, what are the hours, which is going to be 24 hours in this case, and some message. Finally, we need to create a map because we want to send this email to a lot of users, and to keep track of the users and the to-dos, we need to create a map. And finally, we are looping through all the to-dos that we got. And for each to-do, we are keeping count that whether we have already exceeded the maximum amount of to-dos that we want to cover for a particular user. In this case, which is 10, after we have covered 10 to-dos, this will not allow more to-dos for that particular user. That's what we are doing here. Then we create a new task, which is reminder email task, and the task type is going to be due date reminder. Then we also add all the necessary information like user ID, the ID of the to-do title, and the due date. Finally, we put this task inside our queue using this enqueue reminder email function. If there are any errors, we log the error and we skip that, and we continue the loop instead of breaking out of it. Finally, we increase the enqueued count variable so that we can keep track of how many jobs that we put inside the queue for this cron job. Then we log the information, more information, and finally for each user, we log the information that this is the user ID and these are the number of reminders, and this is the count of the reminders that we added and a message for that. And that's about our due date reminders. Similarly, we can go ahead and create other cron jobs. The next one is going to be overdue notification for a particular user. This is what the whole thing going to look like. We start from here. Let's add a comment. This is a completely different kind of cron job. The name is overdue notification job, and this is what the ID of the name is, we can say. Then this is the description, and we are going to use this name and description in the end when we finally construct the executable command, so that the user can print all this description if they are confused about it. Finally, this is the run method, which is actually going to execute the cron jobs. First, we fetch all the overdue to-dos for all the users. We print how many did we find. Then we create a map. Same way, here we are keeping track of whether we have already exceeded 10 to-dos for that particular user. Then we create a new task of type overdue notification. Then we put that task inside our background job processing server. We increment it to keep track of how many tasks that we have put inside the queue. And finally, we log the information here that for this user ID, this was the overdue count for all the users. And we are going to do something similar for the weekly reports also. Let's add a comment here to divide that. And this is for the weekly reports. Here we have a struct called weekly reports job. Then we have a name, a description, then actually the run function. We want to get all the statistics for all the users starting from current timestamp up to the last 1 week. And we log how many did we find. Then we loop through the stats and we collect different information. For example, get all the completed to-dos for that particular user and also all the overdue to-dos for that particular user. Then we create a task, which is the weekly report email task, and we put that task inside our job queue with all the information it needs: the completed count, the active count, overdue count, and the slice of all the populated to-dos here. And then we increment here and print the information about the users here. Similarly, our last cron job is going to be about archiving. After 30 days, all the completed tasks of a user should be put inside archive status. For that, we are going to use this method, and we need to separate it out with a comment. Great. We create a new struct. The name is going to be auto archive. The description is going to be archive all completed to-dos. Then we calculate the cutoff date depending on our config, which in this case is going to be 30 days. Then we log the information, get all the to-dos of the last 30 days, which are of completed status. Then again, we create a map. We keep track of all the to-dos. Then we finally execute this repository method, which is going to take all the to-dos for all the users which are in completed status for the last 30 days, and it's going to change the status to archived. And with that, we have covered all the cron jobs. And the last file that we need is to some way of orchestrating all these different modules of cron. For that, we'll create a file called registry.go. The package is going to be cron, and in this file we are going to keep all our initialization logic for our cron job. So it has a struct which is called job registry, which is a struct, and inside this we have a field called jobs, and that is a map where the key is the string type and the value is a job type. So inside our new job registry initialization function, the first thing that we do is we create a new job registry. We provide it an empty map. Then we register each of the jobs that we created inside this, all 4 of them. And for each of them, we call this register method, which does nothing but takes this job and adds this inside our jobs map. And we do the same thing for all 4 of them. After that, we have a couple of functions here: the help, get, and list. And we are going to use this when we are defining our commands for our cron executable, which we are going to do next. Inside the cmd directory, we'll create a new folder, which we are going to call as cron. And inside that, we'll create another file called main.go. Now in our code base, currently we have 2 separate main.go files. And the reason for that is the first one, the tasker main.go. This is our whole backend executable, our backend application. But this new thing, this new cron module that we created, this is a completely different executable itself, which is going to get triggered by our cron process, which is going to run in our infra level, not in our code base level. But for that to work, we have to expose an executable, expose a path, expose a command using which the cron process can trigger the job. And that's exactly what we are doing inside this main.go file. And this is going to be the content of this main.go. We have a import error here. For that, let's run go mod tidy first. Stop our server mod tidy, and the error is gone. Here we are using this package called Cobra. Cobra is a Go package using which you can build interactive command line applications. It has a lot of utility functions, a lot of workflows, which makes building CLI very easy. For us, it is a very simple use case, but using Cobra, you can build a lot more complicated use cases. For now, let's replace all the instances of Alfred with Tasker. The first thing what we are doing, we are creating a new command type, which is the root command. And this is going to be our job runner. And the command is cron. And inside this root command, we are creating a list command. And the list command internal is going to call this help method, which is going to print this available cron jobs, and it is going to loop through all the jobs, and it is going to print all the description of each of the jobs. That's what we are doing here. And then we are adding this list command inside our root command. Then we are creating a new job registry, which we created here. The registry is the file which is going to orchestrate, which is going to configure all our cron jobs into a single executable. And that's exactly what we are doing here. And we are looping through all the cron jobs that we have defined in our registry using our list function. So list basically goes through all the jobs and it returns the names of all of them. For each job, we are retrieving the job using the get method, which we defined here, which basically takes out the job from the map and returns it. And then we create a new command for that job type using its name, and we add that inside our root command so that we can run commands like cron space due date reminder, cron space weekly reports, etc, etc. And finally, we are executing the command, and we have a utility function called run job here, which is going to create a new instance of the job runner, and finally going to call this method, which is the run method, which is the final method which is actually going to run the job that we have defined in our cron jobs. And with that, we are done with our whole cron module. But if you want to test this out, we cannot do that now because for all the email delivery tasks, we actually need a valid email. For now, we have only created a dummy email. So let's see if we can add a proper legit email. Going back to users, let's create a user. The email should be, I'll provide my email, one.com. The password, let's say the stronger password. Okay, I have added myself as a user manually for now. Then I actually need to log into my account. Since you don't have a front end here, we can impersonate this user using the earlier method that I showed. Let's open the console, and what was the name? This is going to be API test, and when we run this, we'll get the token. And using this, I'll create a couple of to-dos so that in my email, when it sends me, it has some kind of content. So let's go to our API testing and let's replace this token with this one. And let me run get all to-dos. Server is not running, so let's start server. Then let's run this and we get empty because this is a completely new user who has not created any to-do so far. So let me go ahead and create a new to-do. I'll create title as to-do task 1, another one with task 2. Then let me fetch all the to-dos. And for task 2, let me go ahead and complete this. So let's open the update to-do. Status, we are going to make as completed. Let's leave the other two. Let's run this and we can see that completed at is set and the status is completed. Now I have two to-dos, one with the status draft and another with the status completed. Now what we can do, we can trigger our cron jobs. Even though we have not configured any kind of timer or cron process, but since this is an executable, we can test whether it is running fine or not. So for that, we need to keep our background server running because this is where our background job consumers are running. So if this is not active, we cannot test this out. And let me go ahead and from clerk, I'll delete this one. Otherwise we'll get error that this email is not valid. So I'll delete this user. And next up, we'll need to run our cron. Let me go into backend apps/backend. From here, we can say go run cmd/cron, and if we don't provide any kind of arguments here, we get a very informative help screen where we can see what are the commands available and what should we try, etc, etc, because we had created all that in our registry. You can check here. Now what we want to do, we want to trigger this one, the weekly reports. So let me go run cmd cron. We are executing this executable and we want to run the weekly reports cron job, and let's hit enter. We got an error that failed to collect complete to-dos for use of this, cannot find field attachments in return loop. Right, I think I know what's the error. So if we go to to-do repository here, I think in the populated to-do we expect a field called attachments, which we are not providing here, and that's the error. So if we go the top and we can copy this part, we can reuse it down here, delete here. You can go ahead and paste this. And we also need to join this field. So let me also add this one and add the join field here. Great. And we need to do the same thing for this, the join statement, and also attachment is already here. Okay. Oh, I think I messed up. Attachment for this is not present. All right. Let me add this here. Okay. Let's restart our server and try it again. Actually, no user was found. Great. So let's stop our server and let's just go and clear out some of the data of our test user so that we don't get errors. Let me delete this attachment and also this category, and also let's just push this first. No, first I guess we need to delete the attachments, then let's try to delete the category. Nope, we first need to delete the to-do. Inside to-do we have 3 different ones, so let's sort them by created at, and we want to delete the last one, right? The sample to-do. Let's delete this, and then let's come to categories and delete that also, which was created by the test user. Okay, now we'll restart our backend service and we'll try to run this cron job again. Okay, I think it was successful. We are getting some logs here. Let me check my email, and this is the email that we get. There is an issue here if you're able to identify it, but I'll show what the issue is. Now, because of the way that we are exporting our email templates, which is compile time. So we take this React email defined email templates and we convert them into HTML templates, right? Because of that, when we actually pass these values, which are days until due, etc., when we actually trigger the job, this logic does not really run because we have already compiled it into HTML before we even had access to this data. And that is the reason whatever logic that we have written in these templates, whether it is overdue message or weekly report, etc., none of these actually work. One way I can think of to make this work is we can move all this logic, whatever we have here, into our backend, and we take all of this as parameters here as different props, and we don't keep any dynamic values here. That is the only way I can think of to make this workflow work, because this whole recent and React email integration, they work pretty nice when you are building a backend in Node.js or Next.js, etc., because they have a function using which you can generate the HTML template during runtime. You can actually pass a React component when you are sending the email. But since we are using the Go SDK, we don't have that kind of luxury. So the only way to make this work is move all these dynamic elements into the props and format it like this and pass all these values from our backend. And that is the reason this report that we see here, even though these values are correct, this is not working properly. Ideally, it should show 50%, and also some of the other elements are missing because we are depending a lot on the dynamic elements. So if you are following this video and you want to actually work on this project, you can go ahead and make the changes and raise a PR, and I'll be happy to review it and merge it. Or you can just do it in your local and keep it to yourself. No need to raise a PR or anything, and you can keep it as your own learning experience, whatever suits you, right? So with that, we know that our cron executable is working fine. But for testing our cron processes, we actually have to go through our deployment process, which we will do in the next video. And I think we should end this video with this. In the next video, there are 2 remaining tasks. One, we are going to add the integration test, which we were supposed to do in this video. But since this has already been so long, I'll keep this for the next video. So in the next video, we'll add all the integration tests and we'll deploy our project in Sevala. And that's all for this video.